Today we are doing physics. So our task is, what is the flux of a uniform electric field strength through the lateral surface of a truncated cone with cross-sectional radii equals to r and small r. The voltage of the electric field E is the angle alpha with the axis of the cone. So first we need to write down what is given to us. Given is electric field alpha, radii capital of the big base, and the small radii for the small base. And we need to find out the flux of the lateral surface. Lateral surface is this one. So what we have there? Uniform electric field. It is given that uniform electric field. Uniform electric field stands that our electric field is constant. When electric field is constant, it leads to that our charge is equals to 0. It means that inside our isolated cone, we don't have any charge in it. So let's write down the theorem of the Gauss for the flux, which is F is equals to 1 over epsilon 0 multiplied to sum of the charges. But in our case, it is equals to 0. It is first step. But the flux, which is equals to 0, it is for the total cone. But in our cone consists its bases, two small and big bases, and the lateral surface. So it means that each of them has their own flux. So let's write our total flux as a flux of the small base plus flux of the big base plus flux of the lateral surface. And as I said, in our case, it is equals to 0. We have to find out what is the flux of the lateral surface, main character there. And we are writing it as a minus F flux of the small minus F flux of big base. And what we are going to do next? Third step is to renew our knowledge about fluxes. Flux is equals to electric field multiplied to area and multiplied to cosine alpha. There, our basis area is equals to pi r square. So we are putting pi r square on our formula, and it is not the case there because we have also the alpha angle. So I'm going to show you that we're going to know what is the direction of our normals. When the surface is isolated, our normal is looking to the outside. It means that 0, our normal is going to be there, and there are also. So we know the normals, and now I want to duplicate our electric field direction. It will be there, and of course with the same angle. And this also, it will be there with the same angle. To make it more clearly, I'm going to draw it there. So for the small base, it is our electric No, it's not electric, it is our normal radii, small r, I make it even more clear. Radii, electric field direction, and also the angle there. For the second, for the big base, it is our radii, normal, and the electric field with the same angle. So when we are writing the formula of flux for the big base, we know that it is equals to F is equals to electric field multiplied to pi big R squared cosine alpha, because our alpha didn't change. But for the small base, it is other case, because our alpha is not the same. So we are going to find out we are going to use not alpha, we are going to use beta there. But beta is equals to 100 degrees minus alpha. So the formula of the flux is equals to electric field multiplied to pi small r squared cosine 180 minus alpha. 180 minus alpha gives us minus cosine alpha. So we know our fluxes of our base, and let's finish our work from there. The fourth one is F lateral equals to, we have their minus, but we also have their minus, so it will be plus. So it will be electric field pi r squared cosine alpha minus electric field multiplied to pi big r squared cosine alpha. Let's make it more beautiful to our eyes. So where we are putting a small r squared and the big r squared to the other bracket. So it will be rp cosine alpha r squared minus big R squared. So our lateral surface flux is equals to this one. The final answer is this. But there also had a question, why it is negative? It shows that our flux will be negative. And let me answer to your question. Let's take another case for our picture when the alpha degree is equals to 0. That means that our pole lines are going to be horizontal. It's going to be horizontal, and they are going to enter to our cone by its lateral surface by this one, and they are going to coming out by the big base. And if our power lines are entering to the flux, it means that the vector of it is going to be negative. So that means that our answer is correct.